Right, welcome to yet another session, the 13th I think, on our Formatable Refactor. So, where we are now is we're getting to the nitty-gritty bit of the work. So I think since last video what we've done is we've updated all of the templates related to archetypes and copied it here. Like I said, this is going to be a very ugly function. This kind of didn't lie. It is quite ugly. Maybe we can tidy it up a little bit at the end, but for now we just want to make sure it works. And also what we've done is we got our org mode converter. We updated all the models into org because it just makes our life slightly easier. I mean, this is going to be the end destination of the models. They're going to look something like this. But they already are useful as an intermediate step, because what we can do is, instead of doing the whole rigmarole that we've been doing so far of reading the template from here, copying it, going up to our template area, pasting it, looking for the inclusion dependencies function, taking the bits that we're interested in, then pasting it, and then doing whatever it is that we do here, we can simplify the process slightly. Now we've got a text representation of that model. It contains all of the transforms here, and these are just the ones for types, and we could just literally linearly run through these transforms. Contents will be the same, function will be here, so that'll be a bit quicker, I think. Given that we have so many of these to do, speed will be of the essence. I mean, all of these are gonna purpose not inclusion constants, but you see there's quite a few types here. So if we take, for example, hash, we have a few. And that's basically a text representation of what you see here. And that's hash. There's a few there. So all of these have to be transported across. Not all of them will have relevant inclusion dependencies, but most of them will. So with this setup, what we're hoping for is a slightly quicker setup process. And what we'll do as well is we'll follow this linear order instead of the sort of random order that we're following before. So the first type is going to be class header. Now, the only slight problem is that we need some kind of mapping to know the archetype for these guys. And I don't think there will be an obvious place around here with the archetype. That is the only slightly sad thing about this, because the alternative will be to yes, the alternative will be to search for it in this massive list of ours. Should slow things down a little bit, but there you go. I'm wondering if we should create some macros for this. So they're all going to follow a very similar setup, which will be all of these bits here, plus the for loop, and this guy here will be the thing we're hooking on. So if we're this, then we're here. So we will need the inclusion constants, which I believe are going to be here somewhere. Now these inclusion constants are somewhere inside text.cpp, so that's no good. So let's just look for that file. And what we will need is, we will need all of these guys here. Now I think I'm just going to treat these as simple trivial constants, to be honest. I don't think we need anything too clever. So around here, perhaps, let's see, we could say something like perhaps inclusion boosts. Quite a few of them. So I'd say let's get rid of inclusion constants altogether. And then let's make, well, these are quite regular, which is a good thing, so could probably say something like const stud string list, and then let's look for the list, place it there, and then get rid of all of this stuff. Something like this, right? One thing we probably should have done is we should have removed the spaces in between, but there you go. Okay, right, so thanks to the regularity of this, we can probably get away with most of it. Now, okay, this is not completely regular as you'd expect, so let's just go back one. That's that guy there. So what happened here? Predef somehow follows slightly different format. Okay. Decent parser. Seems to have lots of few characters here. I'll gamble on HBP, something like this. Okay. Now then, let's see if our macro will work. No, seems like the boosts ones have got a bit of a different shape. Right, let's leave it at that. Okay, so what we'll do is, well, first we've already got enough here. So what we'll do is perhaps, let's just fix these guys first. And, what happened there? What we'll do to the stud guys is, perhaps just, oops, got a little bit excited there. We don't really want all of them. So we're gonna have to be careful with this. I don't particularly like these replacements where we don't want all. Right, okay, cool. So these first ones should start to make a bit of sense. And the second ones, we could probably just do something like perhaps boosting the score, I guess. Right, so it's getting a bit closer to the final shape then. So boosting the score type traits, and the score is virtual base off. I'll actually skip a few. Boost shared pointer, that looks alright. Interestingly enough, we don't seem to be finding stud string. Not obvious why that would be. I guess we should really include a string. Here, but somebody would have included string by now, to be fair. I think what's happening is that our Emacs has got into a bit of a state. It's happening a lot of that actually. Probably need to do an update to LSP soon. Not quite sure what's going on. Right, so here we are. Now for these ones I'm not going to bother any cleverness. It's probably easy to just hack these manually. Let's do a few. There we are. And use virtual base off is done. And maybe this guy here. Okie doke. Now, many boost archives here. So perhaps can get these done in one go as well. What if our macro would work? Yeah, seems good enough for these. Seems that the problem is when the names are too big for the line, it gets a bit confused. You were not careful with the macro, clearly. So it doesn't really matter. And this guy here. So for the small ones we should... It's a bit of an art writing macros, but to be fair, one thing you should do is to try to write as many macros as possible, to be honest, because what you'll find is as you the more macros you write, the more you start to understand how you write macros that are robust. I bet you that if I was to get rid of 6, yeah, then we don't have the problem with the line wrapping, so it's just the line wrapping was causing the macro to get a little bit funky. And there you are. So now then, probably will do this manually. I mean, clearly this could be macroized, but there you are. So with this we pretty much have all the inclusion constants nicely wrapped as simple variables. Very straightforward. Which then means that we could, whenever we are calling these guys, we can, instead of calling the inclusion constant, we can just call the hacked version. Now of course none of this will be a problem in the future, because in the future these dependencies will have to be explicit. So for now they are hard-coded, which is fine. Have to get that there somewhere. And if we just put our model here, as we were. Now let's have a look at then what we're trying to do here. So the contents of the function were these guys here. And it roughly works like this. So all the builders should really be builder underscore. That solved the first problem. Now we don't really have access to traits. We're trying to get rid of these guys. So let's get rid of this as well. It's clearly not a function, so hopefully that would solve that problem. Now then, we need to obtain the class header archetype qualified name. Now I think that's really easy, really, because we are the class header archetype name for type. So I think all we need to do is to replace types and put an IO there. Of course, you can imagine how much breakage we're going to introduce here. But there you go. Because every time we do one of these guys here, if we make a mistake, well, we're only going to find out at the end. So this guy here will be forward. But still, you can see that this is pretty straightforward mapping. Now here we need the serialization version of the archetype. But notice how this is a class for declarations. So just to avoid problems, let's just search for this guy. That's the guy. And we can say, please. And so you can see that we are largely not changing the logic too much. Now the canonical archetype. Oh, okay, we seem to have a problem with IS forward. Let me just forgot to remove the brackets. Now the canonical archetype. I think that will require some thinking. Let's just give a second for that one. I think we'll be can do for now is just to say, no idea what that is, but let's just hold on. The Ford archetype is exactly like this one, except it's types. The quotes. And then we just self is easy. We already got it here. Oh, actually, notice we seem to be doing something clever here. We are okay, that's fine. There's no particular order. This is just going to the text transforms, but I think we can bypass all of that. And then we have some more traits, some more canonical archetypes. Alrighty, as you can see, we're getting close to the end of it now. These are the 4 declarations. Usually for types. So it's a very mechanical thing we need to do here, I think. Hopefully there's no creativity required. And then finally, the builder. So it's not too bad really, we managed to convert the function without any major problems. And then of course we just need at the end to add somewhere around here, I suspect. Okay, one more error. So I think it's only the canonical stuff that's giving us problems. And that's the for loop. So I think this is quite good. That's we almost done the first one. Okay, so this all looks very good. Now the next thing we need to do is we need to sort out this canonical archetype business. So presumably for each of I'm afraid I've been experimenting with my mod line, so it's looking a bit dodgy at the moment, but we'll have to survive with it. It's flashing a little bit. So what we want is something like the source types, transforms, and then types again. And hopefully, okay, we have the usual problem of arguments out of range. Let's try again. So if I look for traits.cpp here, I look for canonical. Ah, here we are. So I just need the facet qualified name plus the word canonical archetype. So what I'll do actually, I will probably think about this. So there we need the types canonical archetype, and here we need the hash canonical archetype. I think I'm going to be lazy, just copy and paste. I think it's easy enough, really. I think, I suspect this is going to break because I think we're not handling canonical types correctly anymore. But then, nevertheless, one should try. So that's that guy there. And now if we do the same thing for this guy here, and that's going to be almost identical. I think we already have hashes somewhere, didn't we? No. Simple enough. Right, so then there's the canonical archetype then, correct. Okay, cool. So that's basically all we need to do for this function. And that's the very first one of a long list. I mean, we've done 4 already for the archetypes, but there's about 90 other than. I don't think I'm going to record everything, but I'll record an hour's worth or so. This is also much easier to do when we listen to some music. And the other problem, of course, is that we are going all over the place in terms of the type system here, so it's not linear. So this one is an exception, which I don't think we have. So let's start from that. So for this, we probably need quite a few things. We need first an exception here, then we'll probably will need the exception include. And then we will need the exception itself. I'm actually going to be lazy and just put the exception next to the object. Okay, there we have an exception. Yeah, let's see how many we can do in an hour and a bit. I mean, this is not really going to be particularly creative. It's also very annoyingly detailed. It just requires a little bit of luck of concentration, and then you would make a mistake that probably will take a long time to fix. So in this particular case, I don't think we need to uncomment v. I don't. And then I think for these guys here, it's going to be very straightforward. We need to figure out where the exception header types is. And then we need these two guys here in the builder. And as usual, we will. So, what we need to do for these, as you can see here, this is very structurally similar. Soon enough we will get bored and create a function here in Lisp to automate this process. So I reckon that's this guy done. So it varies really. Some of these things will take quite a long time to do. Some of these will be very straightforward. Enumeration we've got already, so perhaps we can just copy and paste all of this stuff. And then you see here that the core of that is just this chap here, which is a canonical archetype, and we know how to make canonical archetypes, and this is probably just the type's canonical archetype. So I'm even gonna just copy all of this. Oh, actually, yeah, we are in types still, so whatever that is. Now we need the enumeration. And that is it. If everything went according to plan. We don't have the enumeration include. We have two objects, interestingly enough. Right, so did we? Yes, I seem to have had exception already. Right, these are the sort of errors that we're going to have a lot of because this requires so much concentration. Such a boring task that this was a proper programming company. This is where you normally get your junior developers involved, because these are the tasks that junior developers tend to be very good at because they're in the process of learning still. Once it gets down to a mechanical task, it becomes a good task for learning because you want people to think about the code and to think about the structure of the code and so on. Doesn't add so much value for people that have been around for too long. So namespace header is an interesting one. We don't seem to be doing anything, which is good, so we can just skip right across. Visitor header I think will be slightly more complicated. It is, we already have visitor, so now you may think, oh well, why are you giving these tasks to the junior developer? It's why can't they have more complicated tasks? But actually, I really enjoyed doing this sort of work when I was junior because part of programming is really to do very boring work without losing concentration. A lot of people don't quite understand that. probably one of the hardest things in programming, is that ability. One thing we're not doing, I think, is not removing. It's very, I think a lot of people think that programming is hard because it requires so much cleverness and so on. But actually, I think not being bored is probably more important than the cleverness. So there we are. We seem to have a problem at the moment with visitor. So what we'll do is first make sure that we've got visitor include. Okay, we seem to have. Second, we need to make sure we've got the right code copied across. Which is this guy here. Yeah, so when I was junior developer, I learned a lot from doing this kind of work, because what people are expecting for you to do is to be able to do this kind of work correctly, which is difficult, you can imagine. It's very easy to get bored, it's very easy to make mistakes. When you make those mistakes, then they're very expensive. And if you don't have the patience to do this kind of work, you're not going to get the refactorings done. Which basically means the code base won't evolve, so it's not about the sexy work really, it's about the boring work most of the time. So we could probably get away with this. Just have to make sure we didn't do a using somewhere. I don't think we did. And then we did the visitor header archetype qualifying name. That normally is called self, but we didn't bother. So I suspect we won't bother here either. Right, and there we are, there's the visitor. For types. Now this is going to be a complicated one. Class implementation. So now class implementation is going to clearly be the same one as we've seen already. Tests. We should have types here somewhere. Types, class implementation area. So class implementation will of course be an object. And we need an else somewhere around here. PM ID not value. And yeah, so this is the thing. I think when we're looking for developers, in my professional job, one of the things we really tend to do is, of course, we always ask the typical interview questions, which probably some of us will probably say they're not exactly the best predictors of your programming skills and so on, but we always try to get an idea of how you deal with boring tasks, because it explains a lot about a programmer, really. So the class header archetype, you can already see here that we could probably benefit from some constants shared between these. But like I said, we're not really going to spend too much time refactoring and making the code look nice. First we just need to get all the code in the right place, and then we worry about the rest. We just use the word v for value in this particular case. So IO archetype, not sure we have IO. We do. Is it the header? It is the header. Oh, let's copy that guy then. And yeah, so the advice I'd give, I mean, while we're doing this boring work, we can probably talk. The advice I'd give to developers starting out is get yourself an open source project, get yourself on an open source project even, and just start from the beginning really. You have access to so many really cool projects these days. Choose a language you like. Okay, we have to be a bit careful here. So if you don't require I/O, so here we have to change the logic. Okay, we'll handle that in a second. Let's try to get the hard bits done first. Where is the I/O? I'm sure we've seen I/O before. It seems like it. Yeah, So in my time, it was not exactly trivial to become a developer. You'd learn from other developers really. It was very hard to learn things unless you had somebody to teach you. And the reason being that in those days there was no internet, all that kind of stuff. And because of that, it was very difficult for you to pick up the right skills needed. And people, when they started work, they were quite behind really. You had to do a lot of training. I mean, and it's not that you didn't do coding at home, it's just the kind of coding you did was much simpler. But it was fun. We learned a lot at home and we did a lot of work. Right, visitors. So we just need a bit of concentration for a second. Right, here we are. So let's just look for that visitor header. Sure, we had that already, don't we? Thought we did visitor a second ago. There we are. And so the result was that it wasn't very easy for you to pick up development. Now I think it's almost like you spoiled for choice. When you're 16 or some suitable age, you can choose an open source project and start following it. You become part of the community. And these projects are very realistic. So if you can commit code to say OpenOffice or to the kernel or any project, it's similar to what you're going to find in a real job. So now the logic here will be to invert this. So what I recommend is, if you want to start a career in development, is I mean, by all means, of course, learn the theory, but as soon as you can, get yourself into an open source project, and then just try to join the community and learn as much as possible, because those projects are quite good. So whilst that's running the test, let's see how we've done about half an hour. So you can see this is not exactly the fastest thing in the world. We've done about 4 or 5. So we don't have to worry about tries, don't have to worry about initializer. Hopefully the built-in header will do nothing. Smart. Okay, so now hopefully the helpers, we don't have to worry at all. Primitives, primitives do have something. So let's have a look at what we got for primitive. Primitive is here. And primitive, so it's really important to just take advantage of the opportunities. You may not know where to start, but that's not the problem. No one really knows what they're doing when they start. What you do though is, if you practice, you will get better at it. And so what we used to do when we were younger is we used to spend a lot of time, people from my generation, programming silly things like games and things that were not very realistic, to be honest. Visual Basic, or Basic even. Those days there was no Visual Basic. Basic games, which were quite different from the things you're supposed to be doing in production, if I'm honest. But if you spend hours on end doing that kind of thing, soon enough you get the gist of programming. And then of course you probably want to go to university and learn. Oh, it's interesting. For declaration, okay, we didn't pick up the right thing. So we really want is the primitive for declarations archetype. So if I just say primitive for declarations, what would that give me? That's probably the guy, I think. Although we have it in types as well, but it's actually interesting. And these days, of course, you have apps and all that sort of stuff. So there's plenty to choose from. It's mainly a case of what you want to do. So the canonical archetype is for types, so I think we can actually just copy this guy here. So yeah, the practice of programming is very, very important. Oh, actually, we are not doing the right thing. So we want something like this. Yes, as I was saying, the practice of programming is very important. The theory is good, very important as well, of course, but you should start with the practice, then learn a bit of theory, and then learn more practice, and so on. rather than learn lots of theory without practicing and things like that. Right, now then, probably have a few syntax errors here. The test passed a second ago, so that's good. Right, and don't have a V. So you can see why I chose V value, just so that I don't have to think about what the name of the variable is. Make this a little bit quicker. And certain things you learn with experience as well is, so this is primitive as well, primitive implementation. Certain things you learn with experience as well is when you're not so experienced at coding, and experience has nothing to do with age, it's numbers of hours coding really. So people that are very young could have a lot of experience if they practice a lot, the usual 10,000 hours and all that sort of stuff. And so what you learn with experience, as I was saying sometimes, is that sometimes doing the quick thing is actually going to cost you longer. So for instance, we could avoid this intermediate refactor and try to just go for the end result. But the problem is, because of the nature of the task, it's actually cheaper to go via this complicated several step refactor than it is to try to do one big long refactor. It's very, very hard sometimes to get all this state in your head, particularly if you're not working full time on something. So that's something you learn with experience. Right, so it's definitely not going to be available yet, I don't think. Feature template bundle. Right, so the feature template bundle is this guy here. I wonder why that would be. Certainly not structural. Suspect it will live somewhere such as features, perhaps. Let's see what the variability feature. So we want the template one, this guy. Right, so, and the class then will be feature template bundle, that's the guy we're interested in. So what we need to do then is we need to create a new section here, void visit. So it's going to be similar to this, and the variability, and we would like right, so something like this. And for good measure, we will keep the order here and make it just after the archetypes. And away we go. And also, I think the other thing you'll find as well as a programmer is programmers learn not to mind too much mechanical work actually. It's weird, I know it's strange, but I think what we try to learn, or the thing you want to learn in the beginning, is how to not think when you're doing this kind of work too much. Just get to that point where it's obvious enough what you're doing that you can get into some kind of autopilot. That's why for this kind of work it's easy for me to talk while doing the work. Of course I think you'll say we're going to have a lot of problems at the end, and I don't doubt you. There's going to be a lot of bugs coming out of this implementation, no doubt about that. But hopefully tracing subsystem will give us a hand. Hopefully. So as you can see here, we got all of this stuff. And we just need, as usual, to change our builder, get rid of these guys, add a few of these. So that's a V. And yeah, it's not exactly glamorous, but is necessary. And this is the thing that then when you go to work and work asks you to do things that are perhaps not so glamorous, because you're used to doing this sort of stuff in your own projects and so on, you don't even think twice about it, which makes you a very valuable member of the team, because what you find is that it's difficult to find people that are willing to do this kind of work. sometimes, depends on the team you're in. But so class 4 declarations. I'm going to copy this one, although I think we want the one in types. But yeah, so it's a. I think people don't quite realize how easy, or easy no, but how within their reach it is to become a professional programmer. We are always, the industry is always looking for people, and there's lots and lots of opportunities, lots of positions. I think compared to any other profession, now you may think I'm exaggerating here, but I think it's probably much easier to get into programming than it is to get into almost every other profession. So for example, say you want to become a lawyer, for instance, it will be extremely difficult for you to become a lawyer. You wouldn't be able to practice law on your own. I mean, you could, I'm not saying you couldn't, but it would be very difficult to find. Even if you try to get yourself into a legal firm as a volunteer, you'd struggle to get in. If you wanted to do the kind of work that gives you the experience you need to then become a professional person in law, there's so many people are fighting for those positions that even to work for free, you'd struggle. Whereas programming is quite, because of the way the industry works, gaining the experience is actually not that difficult because there's so much stuff available. And once you gain the experience, once you've got the right people to give you the references and so on, then you can start to look for work. And now the internet, there's so many tools that enable you to work remotely and so on. I mean, you may not get paid huge amounts of money, but at least you can get a job. And as you gain more experience, perhaps you can move up. Which I think is quite different compared to almost every other profession. I think it's very difficult to get into work, I think, in general. And IT, although it's not trivial, but slightly more accessible than other professions. I mean, say for example you want to become an engineer or something. I mean, can't even begin to imagine how you'd get yourself into an apprenticeship to become an engineer. There's so much competition. Whereas with software, and I'm talking about just for free, really, not a paid intern or so on. Just so much competition, really. Oh, I think we got ourselves into a bit of a tangle here. I think we just forgot. Right, see what MASD says. It's not to say, of course, that you know, it's all bed of roses and everything is trivial and so on. I mean, I don't want to give you that impression. It took me a long time to get into a proper professional job doing really interesting stuff. What was that complaining about? Right, so what are we looking for? Variability initializer header. But I'm just trying to say that relative. Okay, so we have the initializer. Hopefully. Right, so let's just do a bit of a breakdown here of the types of headers we got, so that this looks vaguely sensible. Let's also make a bookmark on the headers because we keep coming here. And then let's look for. So now I guess we're not going to have a variability initializer. So if I just get rid of this. Right, so yeah, so all of this to say that if you're lucky enough that you can live with your parents and survive for a period of time without getting paid, for say a period of a year or two, and you have a lot of discipline, this is the other key. You find yourself open source project that contains the skill set of the thing you want to do. And then I would also not recommend looking into things like gaming and so on, because whilst those things look cool, the problem is it's all about demand and supply, really. there's lots of demand for basic programmers that just do coding, and there's much harder to get involved with something like gaming. So if you choose to become, of course you can find millions of open source projects that are games. Some of them are really realistic. You could get loads of experience and you could become a great game programmer. But then I think you will struggle from experience to get yourself employed as a programmer in the game, because it's so competitive. However, if you choose something else, like say for example if you start getting involved with any of the many .NET projects, or Kotlin, or I don't know, there's millions of these things going on at the moment, you would gain the kind of experience that would get you to a regular programmer job. And I think that will take you in the path, career path, much quicker than, say for example, the sexy gaming and that kind of thing. There we go. Anyway, just a few observations that I've done in my programming career. And I wonder from so I recently did a talk for an association of Angolan programmers, and it was interesting because I realized that a lot of things that we take for granted as more experienced programmers, especially programmers that lived in the Western world for a long time, these things that we think are common knowledge are actually not common knowledge to people outside. People that may live in Luanda, for example, or other slightly less developed places in the world. And these people are desperately trying to figure out how to get into programming. And it surprised me when I started to make comments that everyone was saying, "Oh, how do you do this?" You forget that not everyone's got access to the same information, even though some of it is available on the internet. It's just how to make sense of the wealth of information on the internet. Right, we got a new one here. Feature template bundle. Oh, actually no, that's just the header itself. That's fine. So we just have to remember where we were. And so made me think that perhaps one should try to reach out and mention these experiences. So let's just be careful here. Feature bundle. So the difference here is that one case we have a feature template bundle, the other one is just a feature bundle. And I mean, myself also, I would have appreciated when I was younger to have somebody give me a bit of guidance. Many things we had to find out by ourselves. Right, class for declarations. Hopefully this will be empty. This is good. Finally an easy one. Use the for declarations. Hopefully it will be empty too. Primitive for declarations should be empty too. Okay, in a way this is all very good. Main is empty as well. Right, feature bundle header. Now, feature bundle header will require some work. So let's see, did we do the feature bundle already? No. So feature templates. Suspect it's just that. And then if we go here, this guy, feature bundle. And yeah, to some extent I think it's the responsibility of those people that made it to help out the next generation, really, because we also had people to help us out. I mean, of course we can complain that things were not very straightforward and so on, but I must say that the reason I became a programmer really was not, well, of course I was naturally curious and all that sort of stuff, so you know, you could always say that was because I had that sort of aptitude, but I think more important than the aptitude was the environment. When I was becoming a programmer, it was just around the time where computers were becoming available even to people with not so much money. So we'd have these first generation computers like ZX Spectrum and this kind of thing. And you could always go to your mate's house. There would always be a mate somewhere that had a computer, and you'd have people around, and it's from there that some of us then became programmers, because in that group of people, a few people would start asking questions like, how is this game generated, and so on. And then you'd start swapping tips, and somebody would have enough money to buy a magazine, and then it's a bootstrapping process really. And so whilst we can complain that we didn't have the chances that people have these days, but we also had chances that the people that came before us didn't have. So people from the previous generation wouldn't have a personal computer, so they wouldn't have the opportunity to learn programming at home, which basically meant that only a select few from the previous generation would ever be able to learn anything about computers. So it's I think the key thing of this is that every generation gets it slightly easier. Okay, I'm not totally sure why feature bundle is not available. I thought we had updated the header file, but clearly not. Right, so what's this? Feature template. I think what we really meant to say here is feature bundle. Okay, and now what did we say in the... Yeah, okay, so that's correct. There we are, that was the feature bundle. Now the implementation. So this is a natural process, and also it's interesting to think about that technology has evolved over time really. When we started, we already found technology to be evolving at a very rapid pace. I mean, when I was a kid, you'd go from, I don't know, the first ways of recording data, which was via floppies. We started with 128K, which sounds quite crazy these days, but in those days 128K was pretty cool, and I guess that was the last of the floppies. They were actually floppy, they were not hard. Then from there we went to the 256, then 512. Then soon enough we had a megabyte on a floppy, which was pretty incredible really. And from the megabyte we then ended up with the hard drives became accessible, so then suddenly you could store all this stuff in your hard drive, because you have to remember that the first computers that we had access to didn't actually have hard drives. And it sounds quite amazing really, but even when I think back into what we did, it's quite remarkable. So in the beginning, the computers didn't come with hard drives, they only had floppy disks, which basically meant that you would put a floppy disk with the operating system, you'd load that up, and after the operating system then you'd put a floppy disk with whatever it is that you're trying to run. And so that's pretty crazy if you think about it. Can you imagine? I mean, it's like you wouldn't have installs. I mean, even I tried to remember how things used to work. Oh, actually, let's just pause here for a second. Archetype class header transform. I think we've done that guy already. Archetype class implementation. So now let's just have to be concentrated for a second. Class header, class implementation, and then hopefully, of course, we're going to jump now to facets. Yeah, I mean, I don't quite even remember how things used to work in those days, but I assume that we had to install. Well, there was probably no notion of installing software as such, because of course, what would you install into? You'd have to put in the floppy, and then the floppy would. I think we want to transform. Okay, I'm not really sure why I can't find facet class header. There should have been another of these. So we have facet class header factory, facet class implementation. There should have been a facet class. This is a bit puzzling. We're missing a facet class header factory transform. So facet class header transform, facet class header factory. So okay, one more thing we need to do actually, which we haven't done yet, is we need to commit at some point, because we don't really want to have a massive diff. And of course we don't really have facets here yet, I don't think. No, we don't. Alright, cool. Let me just run the tests. So yeah, I don't quite remember how things used to work back in the day. This is such a long time ago. But yeah, when we had floppies, there was no hard drive, so that basically meant that your computer only had RAM. You'd start off, you'd put the floppy with the operating system, that would load up the OS, and then you would have to put the floppy disk with whatever program you would like to run, and then that would run. But there will be no installation, right? Because I mean, where would you install it to? So you'd have to put the compiler in and that sort of stuff. And I remember that in the beginning we had multiple floppy disks, so we'd have to put the floppy one, then the second floppy, then the third floppy, and so on, and as you moved across. So it was quite strange. So you can imagine that people that come from that environment are quite patient, because we did things that were very, very strange. Alright, the tests are green, so let's just do a commit here. Let's say something like continue working on legacy inclusion dependencies transform. We're going to have a few of these commits, but it doesn't really matter as long as it's green. Right, so where are we then? Facets, I said. So what we need to do now is we need to start the facets. And actually, the problem we have here is we don't seem to have a facet class header transform. I think we might have damaged that somehow. So if we look for the archetype, no, we put that just below the archetype, so let's keep that order. So those were really strange times now that I think about it. I mean, of course we didn't know any better, and clearly for us it was actually great that he could do things like that at all. So whilst you may be thinking, oh my god, how hard were that? For us it was quite the opposite. It was like, oh, it's insanely great that he can do this. And then the hard drives started coming about, and then you'd have like I can't remember what the first hard drive was that I had got my hands on. Probably 10 megabytes maybe, I don't know. And there was only a few computers in school that had hard drives, and of course in those days you had to go to school to access the computers. Only very few people had computers at home, as in PCs, right? We all had sort of ZX Spectrums and that sort of thing. So that was interesting as well. Right, so facet then. Okay, so this is all looking good. Interesting how we define this city-billy here, but we don't use it, so probably we don't really need it. Right, so that looks good. So that's the facet. A bit worried that we are missing. Okay. Let's just make sure. Okay, looks good. And facet class header transform. Okay, next one, the implementation. And so it was, we went through all these phases. And it was quite exciting those days, really, to be honest, because I mean, these days you don't particularly follow computers anymore, right? I mean, who cares about how many megahertz a computer has, or how many megabytes or whatever. But in those days we spent all of our time reading magazines, and we knew quite in a lot of detail how the hardware progressed. I mean, we could tell you, in those days the machines were sort of x8086, then 286, 386 and so on. And things were, you know, the video cards were very, very basic. The sound cards were very basic. You had to install them yourself, and everyone knew how to assemble a computer and so on. It was quite common. I mean, more because of necessity than anything else, really. So we used to help each other out, and people used to save up for bits of hardware when they got their hands on. So what we're trying to do here is the canonical archetype for traits. So I should probably make a bookmark here. Yeah, that would do. which is not much the case anymore, right? People now are quite distinct. I mean, even myself, I haven't assembled a computer for a long time. Occasionally we try to get my kid to do that sort of stuff, but I mean, now you do it for fun rather than anything else. Back in the day, it was there was no other option really. So things have progressed quite a lot. Right, that looks good, I think. Right, now then, go for another type back end. So how are we doing for time then? About an hour. We'll continue for another half hour or so. Maybe the objective of this video will be to finish types, I think. And then I won't bother recording the rest because I think it's just going to be quite boring. You get the gist of what we're doing here. It is not particularly exciting. And also means I'll get to listen to some music while I'm doing this, which is always an improvement in terms of productivity. And yeah, so I think the generations that are coming now, they have a lot of things available to them that weren't to the previous generations. And sometimes I think, because there's so much stuff available now, I think people don't quite realize how much they got available. And I didn't realize this myself until I started talking to the chaps at the APA. We just took these things for granted, really. So sort of, I talk to my friends, everyone is in the same environment, everyone assumes that these things are, people know these things. But in reality, if you have access to the internet, however it is, it may not be brilliant access, but some kind of access, even if you can only do it a few hours a day, and if you've got access to electricity and any kind of half-decent PC, I mean 5-year-old PC, 10-year-old PC even, you can now learn how to program really to a level that's 10 times higher probably than the level I learned, which is I think quite amazing. However, the difficulties now are you need to learn English because sadly there is not a lot of stuff available in other languages, and you do need to have things like access to food and water and that sort of thing, because of course it takes you a long time to become a productive programmer, and during that time somebody has to pay for your keeping, and you have to be very focused as well. I mean, that's the key really. There's no one out there motivating you, so you have to self-motivate, which I think is probably quite a hard thing to do. In some ways, I think that's probably the key thing for a programmer, really. Emacs is blowing a little bit. It's been slow, actually, the last few days. I normally tend to restart Emacs very infrequently, once a month or so. But it's certainly slowing down a bit at the moment. Let's have a look at how long my Emacs has been running for. Probably not very much, to be honest. Just 8 days. I did a restart recently. And when I do a restart, I update all my packages and that kind of thing. The topic of conversation that I get a lot while we're just idly chatting here. People ask me a lot about Emacs. I think there's a lot of things you should do when you're young and you've got sort of infinite time. Because when you start off in IT, before you have a family, when you're quite young, you have a lot of time in your hands. And that's kind of the decisive area of your career, I think. People don't realize this, I didn't realize this at the time. But when you have infinite time, maybe all the way up to when you get to 30 maybe, depending on what you have family to support and that sort of thing, of course, you can afford to experiment with technology quite a lot. And me think, and that's what I thought when I was younger, that's going to last forever. But in reality, there's a very short window until you start having almost no time at all. These days I don't really have time to learn almost anything. I just try to keep up with what I've done already and with the work responsibilities and so forth. And it's almost impossible to pick up new technologies. But when I was younger, pretty much on a daily basis, I'll be exploring with new technology. I just didn't have a focus. That's the problem when you're like 20, you're in your teens all the way up to mid-20s. You just learn stuff for fun. You don't really understand the big picture, how these things fit together. You just, you pick one thing here, and then you have fun for that for a bit, and then pick something else, and then you have some fun for a bit, and so on, without any direction really, because you don't really know what you're going to be doing. And sadly, I think the problem is you don't realize, but this time won't last forever. It's actually a short window of time, and in that short window of time, you need to learn something that's going to make you employable and allow you to progress in your career. So if you can, I would say it's be really useful when you're young to start making a plan of what you think your career is going to be. Now, this sounds quite crazy because, I mean, when you're 15 or whatever, you have absolutely no idea what you're going to be doing. But those that have the advantage of making this kind of plan and trying to understand what it is they try to learn and what are the things that they need to learn in order to get where they're going, have a massive advantage over everybody else, because if you pick up the right technologies and you get enough mastery of them, then you get huge advantage. Oh, actually, we should have looked at this a bit more carefully. What did we just do? I don't think we needed to. So the part class header part doesn't actually require anything, and that doesn't either. So we just wasted some time here because we were talking. So I'm actually going to have to unwind this bit here, and we can probably leave the include. I think no, actually, let's just get rid of the include as well. Yeah, so the people that are more focused and know where they're going have a huge advantage over everybody else. So Archetype class for the factory. Archetype class of the factory. So okay, now then the facets. We haven't done the facet class, I don't think. And so, in a way, you can see how it is that sort of wealth propagates generations. Because what tends to happen with people is that the direction they get from their parents or their environment. And so if you come from a wealthy family where your dad was already into IT, or you're in an environment where everyone is into IT and they already have a lot of experience with it, they'll tell you what you should be doing. And that then gives you the huge advantage that by the time you're going to college or whatever it is that you're doing, you will already be prepared. So as an example, I was lucky enough that I was in an environment where there's a lot of programming people that were going to very good universities in Portugal. And the technical is kind of like the Portuguese MIT. And most of the people that were my teachers were students of that university. They were teaching high school students. And so they were telling us everything we need to know. They would tell us, like, for example, you need to learn Pascal. So we didn't know anything, but your teacher tells you need to learn Pascal, you learn Pascal, and then you do a bit of Pascal, and they'll say, okay, now you understood Pascal. Actually, no one really uses Pascal in practice. You now need to learn C++. And so there you go. You go and you learn C++. And so as a kid, we have absolutely no idea what we're doing. We were just doing whatever we were told, and people told us that it was useful, and then we do it. But that gives us a massive advantage when I compare people that came from our school to people that came from other schools. Even though our school was in a neighborhood that was not particularly well off, it was actually quite deprived. But we were lucky enough to have a set of teachers that were really, I wouldn't say they were good at teaching, but they were very up to speed with technology. And they were very good at giving us the tips of what we should be doing. And also they pushed us very hard. We didn't realize at the time, but in high school we were already doing things that many people only did at uni. For example, one of the tasks we had to do when I was, 16 perhaps, we had to write a word processor. And when I say we had to write the word processor, now you may think, okay, you use a couple of components and so on. You must remember in those days, there wasn't a lot of stuff off the shelf. I couldn't just go to GitHub and copy a few things. And on top of that, we were forbidden to use the TurboVision DLLs. So we couldn't reuse any of the framework that came up with Turbo Pascal. We had to write everything for ourselves. And what I mean by that is we needed to write movement of a cursor, movement of cursor keys, edit boxes, or boxes, dialog boxes, the notion of a UI, a window, all of that they expected us to write from scratch. They didn't mind if we had a collaborative project where students would do bits and then collaborate with each other, but everything had to be written in our class. And we didn't think anything of it. We thought that is how everybody learned, actually, until we finished school, and then we went to talk to other people that had gone to different schools, and everyone was completely surprised that we'd written in a year thousands and thousands of lines of code. We spent all of our time writing code, and we wrote and we did manage to finish the word processor. It wasn't brilliant. It wasn't the best word processor in the world. It's text-based, of course, you can imagine. It had lots of bugs, but it worked. And you can write documents in it. You can save documents. You can load documents, and we had to write everything from scratch. And because of that sheer luck that we had of those teachers, we ended up learning, or a few of us anyway, learned how to program to a very high standard. And that's, I think, is the key thing, I think, is that you're lucky enough, well, if you're not lucky enough to have teachers like that, or an environment like that, you have to make your own environment. Now, we just have to concentrate here for a second. So, we're definitely going to have some bugs here, because we are not really concentrating terribly. So, this is going to be the backend class implementation factory. Yes, so this guy here, I think this is definitely going to be problematic, but it doesn't really matter, we will iron out the bugs at the end. It's most important that we get everything in the right shape, and then, yeah, for starters, we're already mixing and matching things here, but, right, so, backend. Let's just put this guy here for a second. Yeah, so basically the onus on a person that comes from a disadvantaged environment is that you somehow have to figure out all these things by yourself, which is very difficult, really. I don't think I would have been a programmer if it wasn't for my environment. In fact, I'm pretty certain I wouldn't have been. I wouldn't know of half of the things I've learned and so on. This is quite hard to get your head around now. So what are we doing here? Backend class header factory archetype. Oh yes, so we need a header. But we just have to be careful that we pick up the factory, not the transform. So this is actually quite tricky. Backend class implementation, transform. And this is the backend class header factory. These names are so similar that it's very easy to lose track of where you are. So, backend class header factory, I believe. And it's just for good measure, what we'll do is we'll double check that this is really the name of the archetype. That sounds a bit suspicious. Backend class header factory archetype. Backend class header factory. Yeah, I think that's correct. Now then, facet class header factory. I'm actually just going to be a bit lazy here and transform these things here. On the go. Yeah, so that's the difficulty really. One of the reasons why poverty is such a big, sort of difficult thing to solve is it's very difficult to, even though the knowledge is all out there, it's available to everybody now, really, to a lot of people. There's these gates that keep the knowledge locked up, and these are not really gates like they used to be. There are different kinds of gates. For example, electricity. If I take Luanda, my birthplace as an example, maybe you're lucky enough that you you do live in a place where there's enough food and you don't have to worry about food every day. But even then, you still won't be able to become a programmer because you won't be able to access electricity. And the limited bit of electricity you may have, you need to use it for other things, such as, for example, keep the lights on and so on. You have so many different problems that you need to deal on a day-to-day basis that you just haven't got the bandwidth to spend the hours that you need in order to become a programmer. And because people need to work very quickly, so I had a chance to work in Angola last year, and I found lots of really clever people. As expected, there was lots of really good developers, and you could tell many of them went to good universities, like in Brazil and so on. These are obviously the people that are well off. But then the problem I had with them is that they are too focused on just trying to get something going. Everyone in Angola knows how to do a little bit. They know how to do, they can create a website, they can create a basic mobile phone app and so on. But what they don't have is, they don't have the depth of the knowledge of how to make a system end to end. And in order to have that, you need a lot of time. And these people need to start generating money very quickly. They can't afford to be at home not earning. So where are we then? Archetype, facets. I think we made a bit of a mess here. So party is now the first one. Shouldn't really have done that. Important to try to keep some kind of order here. So let's just make sure that we are following the order. So first is archetype. Second is facets. Now we have a feature bundle here, Lord knows why. Then a backend. So that should have been there. Okay, that's the backend. And then after the backend we want the parts. It's important to keep order because if you don't have regularity, then it's impossible to find things. So that's kind of the problem, really. The problem is that whilst we have all these things that are available to many people, you won't be able to make the most of it if you are facing very fundamental survival problems, really. And even the people that are slightly better off are still struggling from a perspective of Europe. In Europe we have the opposite problem, really. We have lots of kids that have lots of potential, but because the education system in some places is not brilliant, like here in England, for example, then they just think they can't do things. It's almost like they're brainwashed to think that they're going to fail. I feel a big shame, really. I mean, I think most Angolans would be very surprised to know, if you go to Inner City London, for example, and look at the students. I mean, they have schools that are absolutely brilliant, facilities that are amazing. I mean, in some places in Angola we struggle to find chairs for people and so on. These kids in London, they have the best facilities, even in deprived neighborhoods. But the schools are still struggling to get students to pass and so on, right? And the reason why, I mean, you can blame the students, but it's also the environment. You live in tough environments, so you're not really motivated to go to school and learn. It's all difficult questions, really. Alrighty, so we're probably running out of time, I think. So we'll just, as I said, finish just the one facet and now, as you can imagine, this will generate a lot of diffs. What we'll do is, once we've finished with all the boring copy and paste bits, we'll do another video. That will add some value, I think, because the debugging of the errors will be interesting, I think. This now is actually just mechanical. This doesn't really add any value because you've seen a few, and you see that's all the same now. There is really not a lot of... okay, another thing we'd like to do is to keep these headers in order, so... This should have been... I mean, sometimes I order them by height or whatever, but which is normally what we do, but there we are. For the purposes of making sure we're not getting lost here. So archetype kind, I think we're very close to finishing type, so so yeah, this is I mean, I think the thing that I'm realizing in my old age, I think, is that when I was a kid, we had this impression that things were separate. Technology was separate from politics, was separate from all these things. But actually, the older you get, the more you realize that all these things are bundled together. It's very difficult to separate politics from poverty, from technology, from the world is all interconnected. And all these things have a consequence. For instance, the fact that we had a very good high school in a very deprived area with really good teachers that kind of didn't really know what high school students were supposed to be doing allowed almost a very large number of people that came from our school to then go and have a career, a real career. And many of us, well, most of us, either left Portugal or the ones that stayed in Portugal ended up in really good jobs. Many of us went back home to Angola and so on. But it was all because our high school was good. It was good to trained us well enough. I mean, not brilliantly, don't take me wrong, this was no private school or anything like that. It was just a normal high school in a inner city area. So it's not like we had the best teachers in the world, but we had teachers that were good enough. And also we had an educational system that was supportive. So for instance, we had grants, we had school meals and all that sort of stuff, because many people couldn't afford to have food. So one of the reasons why they went to school was because school would feed you. And so all these things are connected, really. So it's difficult now to just talk about school without talking about politics, without talking about all these sort of things. Which is quite crazy, really, because you would have thought, when you were younger, you would have thought that all these things are separate, really. But as you get older, you start to realize actually it's impossible to change the world because the world is all interconnected. Hopefully the kids will think differently and they will keep going. Right, now then, what we've done so far is, I think, although this is looking very strange, our indentation is not correct. What we've done so far, I believe, is to populate the types facet. All these guys have been populated. Now I'm not even going to bother to check whether we made typos, because I'm sure there's lots of them. And I can already see the visit is... Oh, okay. What have we done here? There's the part, and there's the part again. Okay, this is one disadvantage of talking and coding. You don't really focus properly. And that costs you time, really. So one thing I recommend, I mean, I do try to create these videos and so on, but I do recommend that you try to, especially if you're learning how to program, try to program in some nice, quiet environment where you can focus. Because concentration is everything in coding. Right, let's try again then. Right, if this compiles, we will... Oh. Okay, see the distraction is costing us money now. Ah, I see what we've done. Okay, no problems. What we've done was very silly. Not so much that we were redefining parts, is that we forgot to update this guy to become archetype kind. I think that will solve the problem. Yeah, concentration is pretty much everything. See all this flashing that we're getting at the moment. I shouldn't have done this really. Let me show you what I've done. I was playing around with some Emacs configuration and I tried to change this mode line to use this space line. don't think it's worked very well. Don't feel like restarting Emacs though. So I'm just gonna have to put up with some flashing, flash photography, I guess. Right, now then, so as usual, we generate everything to make sure the code generator is not broken. And oh, we have forgotten to clock. This is a bit of a mistake. Well, we can work our way backwards in the video, I think. So we are an hour and 25 into it. So an hour and 25 will take us to 11 o'clock roughly. I think we started before that, to be honest. Probably 10:50 maybe. No, actually I'll go with 11 because I can't quite remember. It's better to clock roughly what you've done. Alright, so that's about it really for this video. We can do a simple commit here, and we could say finish types facet in legacy inclusion dependencies transfer. And there we are. Okay, so this is all for this video, and like I said, we're not going to come back now until we finish all of these, because as you can see this is all very boring, and we'll return by the time we finish all of them, including the C# ones. As you can see here, we've got quite a few to go. These are all done, but all of these are not. We'll do all these guys, and then we'll return when we are all the implementation dependencies have been calculated in the new transform. We'll disable the legacy, and we'll see what breaks. Okay, thanks for watching.